700 million years after the Big Bang, the universe was still being born. Galaxies were just beginning to take shape, small, faint, barely there. But in one particular patch of infant sky, something else was already fully grown. A black hole. 50 million times the mass of our Sun. And its galaxy hadn't finished forming yet. This is Abell2744-QSO1. Astronomers have a simpler name for it now. The backwards black hole. To find it, astronomers pointed the James Webb Space Telescope at Abell2744, a massive cluster of galaxies 4 billion light-years away. Abell2744 is so massive, its gravity bends and magnifies the light behind it. A natural lens built from galaxies. Webb used that lens to peer even deeper, past Abell2744, past its light, into a single, faint, red pixel from when the universe was only 5% of its current age. That pixel had a name waiting for it, a little red. Dozens of these have turned up in Webb's deepest images. QSO1 was the one that broke the pattern. In a galaxy like our Milky Way, the central black hole is a rounding error. About 0.1% of the galaxy's total mass. A passenger, not the main event. QSO1 flips that completely. Its black hole isn't a passenger. It's the whole show. 50 million solar masses of black hole, sitting inside a galaxy that barely has any mass at all. The black hole came first, and it came in fully formed. So how do you build something like this? Before there's a galaxy to build it in? For decades, astronomers had one answer for black hole birth. A massive star lives fast and dies violently. Its core collapses. A black hole is born of small, maybe 100 suns. Then it spends billions of years, slowly, patiently growing. But there hasn't been enough time for that here. So theorists proposed something stranger: direct collapse. Take an enormous cloud of primordial gas, almost pure hydrogen and helium. Normally, that cloud would cool, fragment, and light up into thousands of individual stars. But bathe it in enough ultraviolet light first, and something changes. The light destroys the molecule the cloud needs to cool down. Without cooling, the gas can't fragment. It can't become stars. It can only do one thing: fall. All of it at once. Not a star, not a supernova, a single monolithic collapse, straight into a black hole. Already tens of thousands, maybe 1 million, solar masses, skipping the star completely. That is the seed that grew into QSO1. This is still a proposal, not a certainty. So how confident can we actually be? Webb's NR-SPEC instrument split the light from QSO1 into a spectrum. Buried in that spectrum, motion. Gas swirling around the black hole in tight, fast orbits. Exactly the pattern you'd expect from something orbiting a single, compact, massive object. Not spread out starlight, the point mass. And that gas itself told a second story. It was almost pure hydrogen and helium, barely any heavier elements at all. Elements that only come from generations of dying stars. Which means this galaxy hadn't lived through those generations yet. The gas was still practically newborn, and the black hole was already enormous. Here's the problem QSO1 might solve. For years, astronomers have found monster black holes, billions of solar masses, sitting at the center of galaxies less than 1 billion years old. If you start from a small stellar seed, there simply isn't enough time to grow that big. Not even close. QSO1 offers a way out. Start bigger. Skip the long childhood. If direct collapse black holes were common in the early universe, the biggest black holes we see today didn't need extra time. They needed a head start. QSO1 isn't alone either. It belongs to a growing population of little red dots, found across Webb's deepest surveys. Each one, a candidate for the same story. A universe where some black holes were never small to begin with. Webb is still watching. More little red dots are waiting to be measured, each one a chance to test this idea against reality. If direct collapse turns out to be common, we may need to rewrite how every early black hole got its start. If you want to keep exploring the universe's strangest objects with me, subscribe and hit the bell. And tell me in the comments, what should we look at next? Until then, keep looking up.